You can start recording. Everyone, thanks for tuning in. I am Harpal, Celo. We are back with another workshop. Today, the workshop is on building upgradable smart contracts. Today with us, we have Viral from the Celo Devrel team as well. Viral will be going through how we can build upgradable smart contracts, and hopefully this would be helpful for the participants of the hackathon. With that, I would pass it over to Viral. Viral, please introduce yourself and continue with this.
Thank you so much, Arpal. And I'd like to thank all the participants who have participated in Build with Celo. And yeah, so today's talk is about how to build stable smart contracts, because this is a really important like a feature that you can add to a smart contract, I would think, because in hackathon, all people are thinking about is how do I just complete my smart contract and push it live, right? But no one is thinking about in future terms if there is a bug or if you want to add new features or if you want to change your smart contracts. By default, all the smart contracts are immutable, right? Once it's pushed on a blockchain, it cannot be upgraded. But what if you want to do it? If you want to create an upgradable smart contract, you'll have to do it at the start of when contracts or when you first deploy it. So today we'll learn to think in terms of creating upgradable smart contracts, how to deploy it, how to update it, and we'll see it on Celoscan how it looks like online. So yeah, my name is Vival Sangani. I'm a DevRel at Celo Foundation, and I've been working in Web3 for past 1 year now, and I've been creating content on Web3. So you can check out my sites and my blogs. So here we go. Today's agenda is what are smart contracts? We'll go through what actually means when we say upgradable smart contracts. Why do we actually need upgradable smart contracts? Like if there is a reason that smart contracts are immutable on a blockchain, right? Then why do we really need upgradable smart contracts? Then we'll see how does this work on a higher level view. Like we'll see what are proxy contracts, what are admin proxy contracts, and how many types of different upgradable smart contracts are there. And then we'll see a live demo. I'll show the code. We'll deploy it on locally first, and then we'll deploy it on Celo testnet, and we'll see how it goes. And at the end, so what are upgradable smart contracts? A smart contract, upgradable smart contract involves changing the business logic of smart contract while preserving the contract's state. This is a definition taken from Wikipedia, and I know this can be confusing, but in simple terms, upgradable contracts are contracts which are once deployed can be upgraded with some limitations, but it can be upgraded to make it more secure. Like what if, let's say our EVM has a new bug and we want to fix it ASAP because most of the time smart contracts has money, people's money. So we cannot take a risk. So we'll have to upgrade the smart contracts. And so, yeah, and what if we want to add a new feature? Let's say you have a DeFi project and you think of adding loans. That's an upgrade. And you cannot like push an upgrade to an immutable smart contract. You need to create a upgradable smart contract, right? And so, yeah, this is what upgradable smart contracts are. What are the need of smart contracts? Fixing severe bugs. I said like recently we have a huge bug on BSC chain, and before that we have many hacks. These all happen because of bugs. And if you have a table smart contracts, it's as good as gone, because you cannot do anything in that case. It's always a good idea to always create an upgradable smart contract at the beginning. Adding some critical features for the users, like if you take an example of Uniswap, they have 3 different versions, and there's a reason they are creating different versions, because they wanted to add new features. What if they wanted to optimize the gas fees? Like if we talk a year ago, Uniswap, these huge gas fees that you have to pay to just swap a token. But by time, they're optimizing the smart contracts and they're pushing new versions. And this is how you can like do the same in your smart contracts, like upgradable smart contracts, right? And adding new feature just for the usability purpose. If you want to add a new, you can do it with upgradable smart contracts. And there are many more use cases that can be done with smart contracts. So Let's see how does it works. So in normal use, you go to YouTube tutorials or any article tutorials, you'll see that a user just creates a contract and deploy it. And they does not care about proxy contracts. But the moment you add a proxy contract, you are in the way of creating an upgradable smart contracts. How does it work? First, user will create an implementation contract. This is the contract where all your logic, all your variables, functions, and everything lives. This is what you create for your tab. But the time of deploying it, you deploy two smart contracts. First is a implementation smart contract that won't be used directly by your end users. You'll upload a second smart contract called proxy contract. The end user will be using your proxy contract to integrate with implementation contract. In that case, if let's say you have a function called hello world in your implementation contract, user won't be directly calling that function. User will be first calling the proxy content, and proxy content will delegate that function call to implementation content. We are just adding a middle layer, a middle contract that will handle our storage, our function call, and everything will be handled by proxy content. So what does this give you? This is the flexibility to change your implementation content. Let's say this is your version one. Once you deployed it, you have your proxy content pointing to your version one, but you had some logic errors or you have some bugs. Then you create a version two of your smart contract and you just tell your proxy to point it to version two. And as we all know that the end user will be contacting the proxy content, not your implementation content directly. So they are good to go. Like they don't have to change any address because end user will be using the proxy content address to implement use your functions, not the implementation content, right? So that's how this is a very upper level view of how you can create upgradable smart contracts. This is just to understand it. But as we go deeper, like as our smart contract matures and as our smart contract become complex, uh, we need to do some changes. Like we need to add some more security features. Like no one, like your admin should be able to call a proxy function to change the implementation address. Like I don't want any user to just call the proxy server, change the implementation address to some other malicious contract, right? So there are some other functions that needs to be added in the proxy to make it secure and to make it more usable. So there are two types of upgradable smart contracts. First is transparent proxy pattern. So this is as good as like the first contract that we saw. Like we just implement a proxy contract and they handle everything. This is the same contract, and we call it transparent proxy contract. That's the simplest one. I do not recommend using it, but yeah, this is the simplest pattern that we had earlier. Now we have UUPS proxy, and we have it is standard for ERC 1967. So in this case, in transparent proxy, we only had two contracts, proxy and implementation. With UPS, we have three smart contracts. One is our proxy, one is implementation contract, and one is a proxy admin. So all the functions that have the ability to change the implementation of a proxy needs to be called via proxy admin. Like if you want to change the admin or to change the person who can change the version of an proxy, right, then it has to be done via proxy admin. So that this adds an extra level of security where a user cannot call the proxy admin directly. Only an admin can do it, and an admin cannot directly call a proxy. They can only call proxy admins. So this is a fallback that we have to face. Like admin cannot call proxy content. They can only call proxy admin, and a user can only call proxy but cannot call proxy admin. So yeah, that's a higher level view of UUPS proxy. We'll have it going to a live code version of UUPS proxy. So yeah, that's a demo time. So I have a project here, and making an example of a greeter smart contracts. This just takes a greetings and returns back the greetings, but we'll be creating few versions of them. We'll see how we can upgrade it. Here we have a greeter.soul. This is a really simple contract that has a public string, an event that will be emitted, called a value changed. We have a function called greet that will just return a static value of the current greeting variable value. And we have a greeting function. that will just accept a variable and upgrade the value of greeting to the new value and emit the event. That's it. We only have three things, a variable and two functions, one to set the greetings and one to get the greetings. Let's write a test case for it. So, okay, so for all the smart contracts, I have a test cases to understand it better way. So in all the cases, I have a before each function where we'll just do one thing, that's deploying the smart contract. And here we'll do some testing. So first, I'm just getting the contract factory for the greeter. And this is just getting the ABIs and all everything as a factory in the greeter instance. And this is where we deploy it. Greeter.deploy will go to use our RPC, go to the blockchain, and it will deploy our content. Correct. So this is where we start our deployment, and we are just awaiting to get awaiting. Once it's deployed, we'll have a content deployed and an address of the deployed content contract. So this is where testing something like should greet currently before and after changing value. So if we call the set greeting function, pass it a value, and check if the greeting function should be returning the same value. So let's test it local first. Test one greeter, and it's passing. That means that once we set a greeting and we get that greeting, they're exactly same. Now it's time to deploy this content. Correct. So to deploy it, it's not same like in normal cases, like the normally how you deploy it, you get the factory contract and you just call deploy function, it will deploy it, right? But in case of upgradable smart contracts, there is a one more step that needs to be done. All we have to first, anyways, we have to get the contract factory, and on content factory, we cannot just directly call deploy. If we call deploy, it will just deploy that content, but we have to deploy two more contracts, like proxy, admin proxy. To do this, we need upgrades. And this is a class that's available in Hardhat, but not by default. So for that, you need to do one thing, go to Hardhat config, and you'll need to install this package, openzeppelin/hardhat/upgrades. After once you npm install this and then you import it, you will get to use it inside a deploy script. If you don't install it, this will give you an error that there is no upgrades function available. So you'll need to first install it, import it inside a config, and then you can use it inside. So we have a upgrades instance, and inside the upgrade instance, we have a function called deploy proxy. And deploy proxy will just take your factory contract and will deploy it. Now there's three things that this deploy proxy do. It will deploy your implementation contract, that is the contract that you have written, all your logic, all your variables and everything. It will deploy your proxy contract. Proxy contract is where end user will be interacting with, and it will also deploy your admin proxy contract. And in this case, the account that is deploying the contract will be the admin. There are functions like change ownership, change admin that can be used to change the admin of a proxy contract, admin proxy contract. By default, it will be the person who is deploying the contract. So yeah, this will just, in this case, we'll get a greeter instance. And if we do greeter.address, it will not give us an implementation address, but the proxy address, because that's the address that end user will interact with. So greeter.address will give us, just a second, will give us a proxy address, not the implementation address, right? And if you want to get the implementation address, all you have to do is upgrades.erc1967 .get implementation address, and this you'll have to pass in anyway the proxy contract, and it will give you the implementation address of that contract. And the similar way, if you want to know who is the proxy admin, you can do upgrades.erc1967 .get admin address and pass in the proxy address, and you'll get the address. So let's deploy it. I'll deploy to localhost for now. And So these are our three addresses. Please notice that I've only called deploy proxy and it still deployed three contracts. That is the first one of our proxy. This is our proxy that end user will be interacting with. We have implementation address. This both are implementation contracts. That's where logic lives. And we have admin addresses. Admin address is the one that admin can only interact with, right? So also means that the account that I'm using to deploy this cannot interact with the proxy content, right? So the account that I'm used to deploy can only interact with the proxy admin for now. Awesome. So we'll just copy this for future references. We'll need the proxy address. We don't need the implementation or admin address for now, but to deploy the future contract, we definitely gonna need proxy address. So we'll just keep that handy. And let's say you forgot a function called counter. You have already deployed your greeter function that only accepts a greet and greet, but now your manager, your team lead asks you that you forgot to implement a, let's say, counter functionality in your contract. You don't have to rewrite the whole contract, deploy it again. All you can do is just do this 5 lines. Create a contract called greeter v2 and it inherit from greeter contract. In greeter contract, we already have all this functionality. So by nature, v2 will have all those functionalities along with things that we have added. First is a counter variable that keeps a track of a value and increment function that will just increment the counter value by 1. So like we'll write a test for this and then we'll deploy it. So we'll go to the test and again here we have a for each. So this testing script, I'm just testing the version 2 contract, not the ability of the version 2. We have a different test case for that. But in this case, we'll just check if the greetings and the counter functions are working in the version 2 or not. Right. So we simply deploy version 2. We are doing nothing else. We are not interacting with greeter version 1 or anything. We are just deploying version 2, awaiting for its deployment. And once it's deployed, two test cases. First, it should work with the previously showed value. Like even though version 2's code does not have the greeting functions, as you have seen, we have not added any greeting functionality, but since it's inheriting from greeter, it should have the functionality for set greeting and greet. We'll test those things. And we have added the counter feature. We'll check if the counters are working. Like by default, the value should be 0 because we have not defined it. So in Solidity, if you don't define an uint value, it's by default 0. Then we'll call the increment function, and increment will increment the value from 0 to 1, and we'll again expect that value that the value should be equal to 1. So let's test the second script. Okay, there is a mistake in the spelling. It should be v2. Yeah, all the tests are passing. Then let's go and deploy our version 2. Okay, so before going there, we only did the functionality of v2, but we don't know whether it's compatible with v1 or not. So we'll write a new test scripts, and in this case, we'll go from level 0. Like first, we'll deploy our greeting version 1, and then we'll deploy our greeting version 2. So here I'm just getting the factory contract for greeter 1 and greeter 2. In this case, before deploying the video, all I'm doing is calling the deploy proxy for greeter. Again, this will deploy 3 contracts, proxy admin, and implementation. And once the v1, this is the greeter, is deployed, I'm setting the value to WAGMI. Right, before upgrading the version to v2 and setting the greeter value version 1 to WAGMI. Right, now let's deploy v2. So all we have to do to deploy the v2 is just call upgrade proxy in the instance of upgrades. Again, upgrade coming from hard hat, you have a function called upgrade proxy. This takes 2 values. One is the proxy address. And if you remember, like greeter.address will give you by default proxy address. So here we are passing the proxy address of our main contract and we are passing the instance of our version 2. Remember, version 2 still has the functionality of version 1 and version 2. So in this case, we have deployed both the versions, but before deploying the version 2, we have set it the greeting value on version 1 with varme. So normally, you might think that if value in version 1 is varme, then it might not get carried forward in version 2. But that's not the case, because all the variables and all the states and everything, all the data, it's stored inside the proxy and not in the implementation. So the greetings variable that we had, that we set it as varme, is not here, but living inside the proxy content. So even though if we are changing the implementation, all the values are still intact inside our proxy contract. So that means that if we check the greeting value on version 2, that should be varme now, because we have set it as varme in version 1, right? And then we are doing some further testing, like whether all the functions are working fine. So we are again setting the greeting value and checking it. So this is the main thing, like the version 1's value should persist in version 2. So let's do the test. And it's passing. So that clarifies that the data is persistent inside the proxy contract and not in the implementation contract. So let's deploy the version 3, sorry, the version 2. So in our version 2 contract, it's similar to what we did in our before each test case, that we are just uh, getting the address and then deploying it. So before going to version 2, we need to have the address of a deployed contract. And in this case, this is the previous one that I was doing testing with. We'll just do the version 1 again. I'm really sorry, this is the version 2. Yeah. So we need, and for the starting, we just need a contract factory for all the upgradable, all the different versions of contract. Once we have the factory, all we have to do is just again call upgrade proxy, pass in the proxy address and new version contract factory. And all things will be taken care by the hardware upgrade feature. So let's deploy this. First, we'll deploy the version 1. This is our proxy address. We'll replace the proxy address. So in this case, if when we deploy version 2, it will use this as a proxy. So we'll deploy version 2. Yeah. So if you notice, the proxy address remains the same because proxy does not change. And if you go a little bit forward, I guess it's gone. But in the version 3, we'll see that the admin address does not change. The only address that changes the implementation address, even though the last implementation contract is not destroyed, it's still there. But the current implement address will be the one that you just deployed. That's the version 2. So to keep in mind, again, the proxy address does not change, the admin address does not change, the implementation address changes when you upgrade a contract. So yeah, now let's take a case where you need to, you already have implemented a function, but there is some bugs in that function. So you cannot in version 2, we have seen that adding new functions, but in version 3, you'll see that what if you have already you already have a function, but you want to make some changes in that function. So what you can do is you can override that function. In this case, I'm upgrading, inheriting version 3 from version 2. Remember, version 2 has all the counter functions. So once from v2 to v3, we have all those functions, along with I'm adding two new functions. One is the name that's in public variable that just gives you the name that's stored inside it. We have a function called set name that accepts name and update the name, I guess, yeah. And here we are upgrading, overriding a function that's present in our version 1, right? So this is how a level inheritance works. Like version 3 is inherited from version 2, and version 2 is in from version 1. So we can technically override any function inside version 2 and version 1. Greet is a function inside version 1, and we are overriding it. So we'll have to give a override variable. And then what I'm doing is I'm just adding greets, a space, and a name. So if the greeting is hello, then the name is hello, then the value returned is hello space Celo. So that's all I'm doing in this function. So let's test. Yeah. So here I'm just getting contact factory of all the three contracts, doing nothing, just get factory. Then I'm deploying the first version and using deploy proxy. So again, this will deploy three contracts. Then I'm setting the greeting to WAGMI inside of a version 1. And simply I'm just upgrading version 2 and version 3. Like in normal use cases, people won't be upgrading from version 1 to version 3. So just to make it uniform, I'm just upgrading from version 2 to version 3. You can directly go to version 3. That's not an issue. And it again depends on your use cases. So in our test script, I'm upgrading the counter in version 2, incrementing the and just checking the value. And this is just a regular check. All the other functionalities should work. This is our main test case where I'm calling the name value of a name variable that should be empty by default. I'm setting it to Celo. And if you remember on the version 1, we have set greeting to WAGMI. And even though we are in the version 3 right now, but the value should persist. So if we see version 3.greet, it should be WAGMI space and the name. So let's test the version 3 now. And it's passing. So we have defined that override a function and the variables do persist even the versions changes. So let's try the version 3. So to deploy the version 3, it's similar to what we did in version 2, nothing changes. Like first we get the proxy address and then we get factory and then we call upgrade proxy with the proxy address and the factory of version 3 and that's it. So let's deploy the first version first. Take the proxy address, go to version 2 deployed script, upgrade the proxy here, and you can put the same proxy in the version 3 also because again the proxy does not changes. So here if we notice once it's deployed, if you proxy address in both are same, the admin address in both are same, but the implementation address has changed because implementation address is our main logic address, logic contact. That's Vita version 1, version 2, version 3. So we have deployed version 2. Let's go to version 3. And in that also, if we see admin address does not change, the proxy address does not change, but the implementation address is changed because right now we have version 3 pointing back proxy addresses. So yeah, that's the case. And let's take another example. This is the last example. In version 3, we had a public variable called name. But what if your manager tells you that it should not be public, but it should be private? But the fallback in upgradable smart contracts are you cannot change the visibility of a variable. Like you cannot change the value from public to private, right? Because there is a possibility that in the previous version, some users are already using this function as a public variable, and now you cannot come in and put it as private, right? So this is not allowed in upgradable smart contracts. But what you can do is instead of inheriting it from version 3, you can inherit it from version 2 because version 2 does not have this variable. So like we are totally skipping version 3 and we are just inheriting all the functions that are there present in the version 2 and putting it inside version 2. So that means we can skip this variable, like we are not interacting with version 3 code at all. We are totally replacing the variable name with public from private. And we need to all the other functions same, like we have set name and get name. These both functions are doing Now that we have the name as private, we cannot directly call name. So we'll need to get a new function called get name that just return the value of name. We have a function called set name that just sets the name. So it's not required to always inherit from the previous version. You can skip a version if there are restrictions like this where you cannot change the visibility and you have to do it. You can skip a version, or in worst case scenario, you can write the whole contract again from version 1, 2, 3, 4, as many as you have, and you can replace it. But this is a really clean way of writing a code. You can just inherit the previous functionality from a previous version and you can write on top of it. But there might be some worst case conditions where you need to rewrite the whole code. In that case, also you can do it, but make sure that the variable names are same so that the proxy contract that stores the state variable values can map it back again, right? So let's write our fourth test case. Here we are just getting all the factory contracts and we are doing nothing but just first we deploy it and then we upgrade it, upgrade it, upgrade it. And we are just changing the factory from version 2, 3, and 4. And shouldn't set name and get name correctly in value 4. So we are just uh, doing some required testing, like in version 4, we are getting the name, it should be empty by default. Then we are setting it to Celo, and then when we check it, it should be equal. So let's take a test here. And it's passing. So let's deploy it. So for the deployment, let's not go with the usual way where we just call upgrade proxy. Because if we go and look under the hood what exactly upgrade proxy does, it do two things. First, it will deploy an implementation contract. That's this factory contract. It's taking this factory contract and it's just deploying it. That's the first task it does. The second task, it goes to the admin contract, proxy admin contract, and it tells the proxy contract to point to the new implementation contract, right? So here we are doing two things simultaneously with one function only. But there might be some cases in huge projects like Aave, or let's say Unisoft, where you don't you want to test your implementation contract first for asking all the user to use it, right? In that case, you can ask your developers do the first part manually, that is just publishing your implementation contract. And once everything is done, your admin can point the admin proxy admin contract to our new implementation contract. So we'll in the version 4 deployment, we'll do it manually. So let's go to prepare. So we have this function called prepare upgrade, add our upgrades. So here we add upgrades.proxy upgrade proxy that does the two things. Here we can do prepare upgrade, and the prepare upgrade only deploys your implementation contract. That's it. That does not even touches the admin contract. So here I'm again getting the version 4 factory contract, and I'm calling prepare upgrade with again proxy address and the greater version 4. So let me take, if I have it. Okay, I don't have the proxy address. So I will have to deploy all again, but that's good. So if we see, this will only deploy our implementation contract. So in this case, our proxy, that is the address, will still be pointing to version 3 and not version 4. We have only deployed the implementation contract. So let's go again. The first version, copy this. Deploy version 2. Go to version 3 and replace. Go to version 4. Okay. Yeah. So it only have the implementation address because we have not deployed it to admin right now. So again, as I said, like it's a two-step process. So once we have implemented, we have deployed the implementation contract, the admin will have to manually go to the proxy admin contract and they'll have to manually call the function. So here, if here, this is the admin contract. Yeah, this is the admin contract, and admin contract have few features. So let me show you the features. Yeah. If you go to proxy admin contract at the OpenZeppelin, you'll see all the functions that are available for the admin. And one of them is change proxy admin. And this is the one that we want. That's upgrade function that will take the proxy address and the implementation address. This is the function that the proxy admin will have to call it manually. And in that case, the already deployed implementation contract will be pointed by our proxy contract. So yeah, these are the other functions available like get proxy implementation. Like this will give you the current implementation contract. Then this will give you the current admin contract, proxy admin contract. They can even change the proxy admin and they can do some additional functions like upgrade and call the data directly. And they have a owner, renounce ownership, transfer ownership functions also available. So yeah, let me show you how easy it is to deploy it on Celo. All you have to do is just go to your hardhat config. And here we have two networks, that is the option and AlphaJOS. So all you have to do is just go to AlphaJOS, put in your RPC URL and provide a private key that you want to deploy it with. All you have to do is just while deploying it, just change the local host to AlphaJOS. Once you deploy it, it will take some time, like 10 seconds or maybe something. And your contacts are upgradable on live on Celo testnet. That's all it takes to deploy it on Celo. No configuration is required. Like whatever you're deploying it on, Hardhat directly comes with that's EVM, right? Like once you have your code ready and everything is working locally on local blockchain, it should work on EVM. We'll wait for it some time. I have Explorer over here. Once it's deployed, I'll just show you how it looks. Again, it's taking a lot of time for the first one because we are deploying three contracts, proxy, admin, and implementation. But with the version 2, version 3, it will be a little bit faster because we'll be only deploying one contract, but we'll be making one contract call. So that should be pretty quick. But this might take a long.
While you're waiting to deploy, can we take one question?
Yeah, sure.
So there's a question which is, the proxy be set to disable future upgrades?
You can call this renounce ownership. In that case, like there won't be any owner, so future upgrades would be paused, but there is no, I don't think so there is any function to pause or stop the version upgrades. That's totally in the hands of admin. Okay, so before we take, let's just see, this is the proxy address. We go to the Explorer. You can see that's 45 seconds ago deployed. This is a proxy contract. Like if you go in the contract, you will find that this won't contain our implementation code. It's the upgradable contracts like provided by OpenZeppelin. So yeah, that's the presentation. Okay. Yeah. We can take the questions now.
Awesome. First of all, thank you for doing this session. And yeah, thank you for taking out the time to explain upgradable contracts. And everyone, please feel free to use the Q&A to drop in your questions, or you can even use the webinar chat. One of the questions that we have, okay, yeah, can we get the Git repo link? So if
I
this project is
haven't
on Git,
I haven't pushed it yet, but I'll share it in the Discord after this meet. Yeah, sure.
awesome. So it will be shared in Discord, and the link to the Discord is in the chat. So feel free to join the Discord server. You will be able to find the link there. Okay. Do we need to deploy the proxy contract every time we have a new version?
Sir, can you repeat the question?
We have question. Do we need to deploy the proxy contract every time we have a new version?
No, so you'll have to keep the configuration that we just saw in the hard hat, and you just need to have the address of your proxy contract and your new version. That's it. You don't have to deploy it again. That's a one-time process. Even the admin proxy and proxy both needs to be deployed once.
Awesome. That should have answered the question. If anybody wants to have their mic open, if they want to speak, to raise your hand.
Hey, my question is, so if you have an upgradable contract that holds funds, does that is it like a security risk for users because you could like rug pull after an update, or is there a way to like prevent that?
So I don't think so. There is a way to prevent it. Like we have to trust the developers or the admins, like we do with Aave. Aave is upgradable. Like even any job that shows billions of dollars is upgradable. So like that's the thing. Like before investing or putting our money, we need to check who the admin is. Like in case of Ethereum, ENS, so we should check like who the admin is, and once the contract has all the certifications or all the audits, and that depends on us. Like we'll have to be careful about it.
Got it.
We have another question is from Andy. Are we allowed to use WAGMI instead of Celo development kit?
Yes, and I guess yeah, it's not a requirement. It's just a tooling help that we provide. But yeah, totally you can use Valve.
Awesome. We have a question from Mesh as well. He says that I'm new in this. Which coding is going here, and what are we trying to explain here? Can you give like a brief of what is the session
Yeah.
about?
Hey Umesh. So this talk was a kind of an intermediate to advanced talk. Like in the beginners, we have how to write a smart contracts and what is solidity and how to deploy it. But if we talk about proper company that we are forming on our smart contracts, where we'll be taking funds from the users and we have to safeguard it, we should think in terms of like adaptability. And in that case, we might want to use upgradable contracts, where once you have deployed a contract, there might be some worst case scenarios where you have to upgrade it. Like you need to, like there are no other cases, otherwise might be a big hack. In that case, you'll have to think ahead, and like when you start writing a smart contract, you need to think in a way that how to do this in upgradable way, like to safeguard the future versions or future hacks or anything.
Awesome. I've also pasted a link to the playlist which contains all the workshops you've done so far. So in case if this is all very new to you, you can use the play watch the previous workshops that we have done, where we have a lot more basic videos as we have another question from Henry. Do we get development support in terms of resources from Celo? Sometimes we find us stuck as a team and getting support is sometimes hard.
Yeah,
Would
so
you like to take
like
this? Yeah.
And we are like constantly doing develop office hours. Like Harpal is doing twice a week. I am also trying to do one or two every week. So you can just go to the Discord, and on the top left you will find the event section where you can see like we have all the developer office hours scheduled. In developer office hours, usually 30 minutes to 1 hour, where we help other developers. Like if you have any doubts, if you just want to showcase your project, if you want to get reviews from us, you can just join, you can ask your question, you can present your screen, or you can like take our suggestions on your project. So you can join. Most probably we have 3 to 4 office hours a week, and you can ask for help.
Awesome. Yeah. Feel free to raise your hands, people, if you want to speak up, and also use the chat. Uh, I guess that's all the questions. Oh, okay, one more question. We'll be able to look at the code after the session. So yeah, once this session ends, we will be sharing the link of the GitHub project. Uh, and yeah, then you will be able to see the. That's another question from Sufyan, which says, can we do this through Redux?
I guess not. I haven't tried it, but I think to you deploy it with Upgradeable, you'll need Truffle or Hardhat. Like OpenZeppelin has provided support for Hardhat and OpenZeppelin. There's this package that I've installed called Hardhat-upgrades. If you saw it in the presentation, so this is the package that you'll need to deploy it. So I don't think so you can do it with Remix.
Question from Henry. So what happens if one makes more than three get disqualified? I think you won't get disqualified. Three is like the minimum requirement. There's no upper bound to it, so I recommend making as many commits as possible, but not less than three. Awesome. Um, yes, you will be getting the GitHub link in Discord, and the link to the Discord server is in the chat. In case you must have, will paste it again. Awesome. I think we don't have any more questions. So thank you everyone for joining in. Thank you, Viral, for doing the presentation. And yeah, see you
Thank you
everyone in
everyone
the
for
next
joining.
workshop.
Goodbye.
Thanks,
Bye everyone.
everyone.